Welcome everyone. Today's session on JavaFX GUI programming in Java. This presentation is designed to provide you with a solid foundation in creating graphical user interfaces using JavaFX, Java's modern and powerful GUI toolkit. Whether you are a beginner stepping into the world of desktop applications or someone transitioning from Swing, this presentation will guide you through everything you need to know to build responsive and interactive Java applications with rich visual features. It includes support for hardware accelerated graphics, modern layout containers, built-in UI controls, CSS styling, and a declarative XML-based UI definition approach through FXML. Those features enable developers to design and code visual appealing interfaces in a more efficient and structured manner. By the end of this session, you will be able to build a full functional JavaFX application, understand how JavaFX components interact, and apply best practices to separate design from logic, all while keeping performance and maintainable in mind. Let's begin your journey into the modern world of GUI development in Java with JavaFX. In this slide, let's go over the agenda for today's session on JavaFX GUI programming in Java. We'll be covering several important topics in a logical step by step manner, ensuring that by the end of the session you are confident in creating JavaFX based applications from scratch. We'll begin with a quick introduction to JavaFX, where we will understand what JavaFX is, why it was introduced, and how it compares to the older Swing framework. This foundational understanding will help you appreciate the evaluation of Java GUI programming. Next, we will explore the JavaFX architecture, how the framework is structured, and how its core elements such as application stage and scene interact with each other to form a working JavaFX application. You will also learn about the scene graph, which represents the hierarchical structure of all UI elements in a scene. Finally, we conclude with a discussion on Scene Builder, JavaFX properties, 2D graphics, deployment, and a practical wrap up. What is JavaFX? JavaFX is a modern, powerful framework developed by Oracle for building rich and visual appealing desktop applications in Java. It was introduced as a successor to the older Swing library and has since become the go-to GUI toolkit for new Java desktop projects. JavaFX enables developers to create modern UIs with a wide range of features like advanced graphics, animations, media playback, and web integration. One of the biggest advantages of JavaFX is its ability to support rich internet applications. Those are desktop applications that look and behave more like modern web applications, offering a better user experiences with JavaFX developers and build applications that include dynamic content, smooth transitions, and responsive layouts. In addition, JavaFX is a fully compatible with modern IDEs like Eclipse and NetBeans with built-in support for event handling, layout management, and property binding. JavaFX significantly reduces the amount of code you need to write for building attractive interfaces. Understanding the difference between JavaFX and Swing is crucial, especially if you are transitioning from older Java desktop applications to modern GUI development. Both frameworks are used to create graphical user interfaces in Java, but they vary significantly in terms of capabilities, ease of use, and visual appeal. Swing is Java's traditional GUI toolkit introduced in the late 1990s. It is built entirely in Java and offers a wide range of UI components. However, Swing's look and feel is outdated by today's standards, and customizing the appearance often requires substantial effort. While it is stable and mature, it lacks many modern features such as advanced animation, styling through CSS, or declarative UI building through XML. JavaFX, on the other hand, is Oracle's more recent GUI framework. It is designed to overcome the limitations of Swing and bring Java UI development up to par with modern technologies. JavaFX provides support for hardware accelerated graphics, rich media, FXML based UI design, and CSS styling. You can build complex layouts more easily using layout pans and also integrate video, audio, and web content effortlessly. Another key feature of JavaFX is its built-in property binding mechanism, which allows automatic updates to the UI when underlying data changes, something that requires manual implementation in Swing. JavaFX application structure. To effectively build applications with JavaFX, it's important to first understand the core application structure. Every JavaFX program follows a well defined template that revolves around extending the application class, which serves as the entry point for all JavaFX applications. The central method you must override is the start method. This method is automatically called by the JavaFX runtime when the application launches. Inside this method, you set up the initial stage, create a scene, and then display everything to the user. Here, how the hierarchy works. Application. This is the main class you create. It acts as a container for launching your JavaFX app. Stage. Think of this as your main window. It's like the frame in Swing. Scene. This is the content inside the stage. It holds all UI elements known as nodes. Nodes, those includes buttons, labels, text fields, layouts, etc. Understanding this foundation is key before dividing into layouts, controls, and other advanced JavaFX features. Scene graph. The scene graph is a core concept in JavaFX and forms the structural backbone of any graphical user interface. It is essential a tree-like data structure that organizes all graphical elements in a hierarchical manner. Understanding the scene graph is crucial for effectively managing layout, rendering, and event handling in a JavaFX application. At the root of every scene graph is a parent node such as layout container. This node contains child nodes which can be other layout containers or UI controls like buttons, label, text fields, and so on. Those children can themselves have children, forming a nested structure of visual elements, just like the branches of a tree. The scene graph allows JavaFX to efficiently render UI components, apply transformations, and handle events. Since each node in the graph can listen to events, perform animations, or update based on data, it provides a flexible way to build interactive UIs. Another advantage is grouping by grouping nodes. You can apply styles, effects, or transformations to the entire group at once. This is useful for complex UIs or when performing animations. The scene graph is not just about layout, it's the framework that ties together all visual elements in JavaFX. Mastering it gives you powerful control over your application's design and behavior. Controls. JavaFX offers a rich set of UI controls, the visual elements that users interact with, such as buttons, labels, text fields, checkboxes, radio buttons, and more. Those controls are essentially for building functional and user friendly interfaces in any JavaFX application. All JavaFX controls are part of the JavaFX.scene.control package and are represented as nodes in the scene graph. That means they can be added to layout pans and styled just like any other visual element. Let's go through some of the most common controls. Label displays non-editable text, great for instructions or output. Button performs an action when clicked. Buttons often trigger events which we handle using event listeners. Text field, a single line input field for text, commonly used for user login forms, search bars, etc. Password field, similar to text field but hides the input text for privacy. Checkbox represents an option that can be selected or deselected independently. Radio button, used in groups for mutually exclusive selections, meaning only one option can be selected at a time. Combo box, a drop down list for selecting from multiple predefined options. Those controls are highly customizable. You can set their text, style them with CSS, them to observable properties, and handle their actions with lambda expressions or controller methods. Understanding how to effectively use JavaFX controls is key to building engaging and interactive user interfaces. As we move forward, we will explore how to place those controls into layout containers and respond to your user events. Label and button example. Let's now take a closer look at two of the most commonly used JavaFX controls, the label and the button. Those elements form the foundation for almost every interactive UI, and understanding how to create and use them is a vital step in JavaFX development. A label is a non-editable text component. It's used to display static content like headings, messages, or output values. To create a label in JavaFX, you simply write. This creates a label that displays the word hello. You can later update its content dynamically using label.setText with brackets new message. Next, let's look at the button. Buttons are used to trigger actions such as submitting a form or showing a message. Here, how you create a basic button. To respond to your interaction, you use the setOnAction method and pass in a lambda expressions to handle the event. You typically place those controls inside layout containers like VBox or HBox and then add the container to your scene. This simple example shows the power of JavaFX component based design. Practicing with a label and button interactions is a great way to get started with event driven programming in JavaFX. Handling events. Event handling is a fundamental concept in GUI programming. In JavaFX, handling events means responding to user interactions such as clicking a button, typing in a text field, or selecting an item from a drop-down. JavaFX provides a powerful way to manage those interactions using event listeners and lambda expressions. Let's begin with a basic example handling a button click. Use the setOnAction method to define what should happen when the button is pressed. Here the lambda expression defines the action to take when the button is clicked. The parameter represents the action event triggered by the click. You can also assign more complex behavior inside the lambda, such as updating UI components, opening new windows, or processing user input. For instance, you might update a label when a button is clicked. JavaFX supports many types of events, not just action events. For example, mouse event, key event, window event. Each JavaFX control has a built-in support for various events, making it easy to define interactive behavior across your application. With Java 8 plus features like Lambda expressions, JavaFX makes event handling cleaner and more concise. Mastering events is essentially for making your applications dynamically and user friendly. Text field and password field. In any application that takes user input, form fields are essential. In JavaFX, two commonly used input controls are text field and password field. Those controls allow user to enter data into your application and they are foundational for building login screens, search bars, registration forms, and much more. Let's start with text field. A text field is a single line input box where users can type in text. Next is password field, which functions similarly but masks the input for security. It's perfect for login forms where the user enters confidential data like passwords. Both of those controls can be styled with CSS and placed inside layout containers like VBox, HBox, or GridePan. You can also add prompt text, a hint that appears when the field is empty, using setPromptText method. Together, text field and password field help make your JavaFX applications interactive and secure, forming the core of user data collection. Radio button and toggle group. When building forms are options where a user must choose only one item from a set, radio buttons are the ideal control in JavaFX. Unlike checkboxes, which allow multiple selections, radio buttons are designed for mutually exclusive choices, and JavaFX handles these elegantly using a toggle group. A radio button represents a selectable option. To use multiple radio buttons where only one can be selected at a time, you must assign them to the same toggle group. You can also add listeners to the toggle group to detect selection changes in real time. Styling and arranging radio buttons is straightforward using layout pans like VBox or Grid Pan. You can align them vertically or horizontally, and you can group them logically in your UI for better user experience. Radio buttons are especially useful in surveys, quizzes, setting menus, and anywhere users must make a single definitive choice. Understanding how to use radio buttons with toggle groups is a key for creating clean, organized interfaces that guide user input effectively. Checkbox and combo box. In JavaFX, checkbox and combo box are essential controls for enabling users to make selections from predefined options. They each serve different purposes. Checkboxes allow multiple selections, while combo boxes offer a drop down menu for selecting a single item. Let's start with checkbox. A checkbox is a UI component that lets the user toggle a value on or off. It's ideal when you want the user to select multiple options independently, such as selecting multiple hobbies, skills, or preferences. You can also attach listeners to handle changes in real time. Now let's look at combo box. A combo box is a drop-down list that allows user to pick one option from many. This is great for space saving UIs or selecting items from a long list, like choosing a country, state, or product category. Combo boxes are also support editable input if needed, allowing user to type and select, making them very easy. In checkboxes are best for multiple independent selections, while combo boxes offer a clean and compact way to pick one from many. Layouts overview. In any graphical application, arranging UI components in a visual, appealing, and functional way is essential. In JavaFX, this task is handled by layouts, also known as layout pans. Layouts define how nodes such as buttons, labels, and text fields are organized inside a scene. JavaFX provides several built-in layout managers, each with its own rules for positioning elements. Those layout pans simplify UI design by automatically adjusting positions, sizes, and alignments, making your interface more responsive and maintainable. Let's go over the most common layout types. Pan. The base layout class, it offers manual placement of child nodes not recommended for dynamic or resizable UIs. VBox or vertical box arranges elements vertically one below the other, great for stacking controls like labels and input fields. Hbox or horizontal box arranges elements horizontally side by side, useful for toolbar or row based forms. Border pan divides the window into 5 regions: top, bottom, left, right, and center. Ideal for dashboards or applications with a header and sidebar. Grid pan organizes notes in rows and columns. Excellent for structured forms or spreadsheets. Stack pan stacks notes on top of each other, often used for overlays or combining multiple elements in one spot. By combining those layers, nesting a vertical box inside a border pan, for example, you can build complex interfaces with ease. Learning which layout to use in each situation is a key skill in JavaFX development. Using vertical box and horizontal box, two of the most frequently used layout containers in JavaFX are vertical box and horizontal box. Those simple yet powerful layouts help you arrange UI components either vertical or horizontal. They're ideal for building clean, organized interfaces quickly and are often used together with larger layouts. Let's start with vertical box. As the name suggests, a VBox lays out its children in a single vertical column from a top to bottom. This is will place the label text field and button in a stacked format. You can control spacing between nodes using set spacing method and set padding around the VBox with a set padding method. Next is horizontal box, which arranges its children in a single horizontal row from left to right. This layout is perfect for toolbars, button groups, and row informs like vertical box. You can also control spacing and padding for layout control. Both VBox and HBox spot alignment properties, allowing you to align content to the top, center, or bottom. Another useful feature is that you can nest layouts. For instance, you can place an HBox inside a VBox to achieve complex grid-like UI structures. Overall, VBox and HBox provide a solid foundation for must UI arrangements, and mastering them will enable you to design interfaces that are both functional and user friendly. Border pan layout. The border pan is one of the most easy and widely used layout containers in JavaFX. It divides the scene into five different regions: top, bottom, left, right, and center. This layout is ideal when building structured applications like dashboards, forms, or media players where you want clearly defined selections in your UI. Here, how the regions are organized. Top, often used for menus, toolbars, or application headers. Bottom, typically contains status bars or footers. Left, suitable for navigation panels, lists, or menus. Right, can be used for additional options or sidebars. Center, the main content area, the most prominent region. To use a border pan, you instantiated it and then assign nodes to its regions. The real strength of border pan lies in how it naturally adapts to Windows resizing. For example, the center region automatically expands to take up any remaining space, while the top and bottom maintain their height. It also works well when combining with other layouts. You can next VBox or HBox inside the regions for even more control. Mastering border pan allows you to create balanced and visual clean layouts that are easy to navigate and scale across various screen sizes. Grid pan layout. The grid pan layout in JavaFX is a powerful and flexible container that arranges nodes in a grid or rows and columns. It's especially useful for creating forms, calculators, and any structured UI where elements need to align in rows and columns. With GridPan, each component is placed at a specific cell location using coordinates. You can define how many rows and columns your layout has simply by where you place nodes. You can control the spacing between cells using set h gap for horizontal spacing and set v gap for vertical spacing. Padding around the entire grind can be set using set padding. GridPan also allows components to span multiple rows or columns. For example, you might have a title label that spans across all columns. This makes it extremely adaptable for more complex layouts. GridPan aligns everything neatly, ensuring your UI is professional and organized. If you are building a form or structured input screen, GridPan is likely your best layout option in JavaFX. Anchor pan and stack pan. In JavaFX, anchor pan and stack pan are two important layout containers that offers unique ways of positioning and layering UI components. They provide additional control in situations where traditional layouts like VBox or Grid pan may not be sufficient. Let's start with anchor pan. This layout allows you to position nodes relative to the edges of the container. You can anchor elements to the top, bottom, left, or right by specifying how far they are from each edge. This is especially helpful when building resizable UIs where components need to stay in fixed positions relative to the Windows edges. Now let's explore StackPan. As the name suggests, StackPan stacks nodes on top of each other. The last added node appears on top. This layout is useful when layering components is required. For example, placing a label over an image or showing a loading spinner over the main content. Stackpan automatically centers its children by default, but you can customize alignment using stackpan.setAlignment method for each node. Together, anchorpan and stackpan give you control over positioning and layering, making them essential for advanced JavaFX layout management. Styling with CSS. One of the standout features of JavaFX is its built-in support for CSS-based styling, which allows developers to separate design from logic and create modern, visual appealing user interfaces. Just like in a web development, CSS in JavaFX is used to style UI elements such as buttons, labels, text fields, and entire layout pans. Using CSS in JavaFX provides several benefits: clean and centralized style definitions, easier UI customization and them switching, better separation of concerns, improving code readability and maintenance. There are two ways to apply CSS in JavaFX: inline styles and external style sheets. First one, inline styling. You can directly set styles on a node using the set style method. Second one, external style sheet. A better approach is to define your styles in a separate .css file. You can style nearly every aspect of JavaFX controls, padding, border, radius, shadows, and much more, making your applications look clean, professional, and modern. CSS styling in JavaFX also supports class and ID selectors, enabling you to style groups of elements or individual nodes preciously. This gives you total control over your application's appearance without cluttering your Java code. Applying CSS to JavaFX. Now that you understand the role of CSS in JavaFX, let's explore how to apply CSS styles to your JavaFX application effectively. JavaFX uses a styling mechanism similar to HTML and web development, giving you the power of theme and enhances your UI without changing any business logic. To apply CSS in JavaFX, you typically create a .css file that defines the styles for various UI components. Then you attach this style sheet to the scene object in your JavaFX application using the getStyleSheets.add method. Make sure the CSS file is located in the current directory. This modular and flexible approach lets you design visual appealing UIs while keeping your Java code clean and focused on logic. FXML overview. JavaFX offers a powerful feature called FXML, which allows you to define the user interface in XML format, completely separate from your Java logic. This approach is similar to how HTML defines structure in web development, making it easier to maintain, design, and scale your applications. FXML is ideal for teams or individuals who want to focus separately on UI design and backend logic. Designers can work on the layout in a FXML file while developers implement the event handling and logic in the corresponding controller class. The benefits of using FXML include clear separation of design and logic, simplified and declarative layout structure, better readability and collaboration in large projects, support for drag and drop UI design by tools like Scene Builder. FXML brings structure and scalability to your JavaFX apps, making it easier to design clean and maintainable user interfaces. Loading FXML files. Once you have created an FXML file to define your JavaFX interface, the next step is to load that FXML file into your Java application. This is done using the FXML loader class, which reads the XML layout, creates the corresponding UI nodes, and connects them with the controller logic defined in your Java class. Here step-by-step process to load an FXML file in a JavaFX application. First one, create the FXML file, for example main layout.fxml. This file contains your UI structure written in XML format. Second one, designate a controller class in your fxml using the fx colon controller attribute, which links your UI to a Java class that contains the logic. This method allows for a clean separation of concerns, helping you organize your project better, especially as it grows in size and complexity. Loading fxml files dynamically enables modular, scalable UI development and promotes reusability across different parts of your JavaFX applications. Controllers in fxml. In JavaFX, when using fxml to define your user interface, the actually logic behind the UI, like event handling, data processing, and state management, is handled by a controller class. This controller bridges the gap between the fxml layout and your Java application logic. A controller is a regular Java class that you link to your fxml file using the fx colon controller attributes in the root XML element. Inside the controller class, you can first one declare UI components with at the rate of fxml annotations to gain access to them in code. Second one, write event handling methods that are connected to UI actions like button clicks or text input. Third one, initialize the UI using the initialize method, which is automatically called once the fxml file has been loaded. Controllers in fxml promote a clean separation between view and logic, making your code base more modular, textable, and easier to maintain. Integrating JavaFX and Scene Builder. One of the most developer friendly tool in the JavaFX ecosystem is Scene Builder, a visual drag and drop interface designer for building fxml files without writing XML manually. It simplifies the UI design process and makes working with JavaFX more efficient, especially for beginners or teams involving UI or UX designers. Scene Builders allows you to visual arrange JavaFX components like buttons, labels, and pans, customize layout and components properties, automatically generate the corresponding fxml file like UI elements to controller classes using simple property pans. Scene Builder significantly reduces the time required for designing complex layouts, ensures fxml validity, and improves collaboration between developers and designers. It allows keeps your Java code clean by offloading layout responsibilities to the fxml file. JavaFX properties. One of the most powerful features of JavaFX is its property binding system, which it built around JavaFX properties. Those are special types of variables that are observable and bindable, meaning they can automatically update the UI when data changes and vice versa. JavaFX provides property classes for all major data types: string property for string values, integer property, double property, boolean property for primitive types, object property for objects of any custom or standard class. Even more powerful is binding. JavaFX allows you to bind one property to another so that any change in one is automatically reflected in another. There are two types of binding: unidirectional binding updates in one direction only. Bidirectional binding keeps both properties in sync. Using properties simplifies UI development, reduces boilerplate code, and leads to more responsive and interactive applications. JavaFX properties empower you to build smarter, more dynamic UIs with minimal effort. Binding in JavaFX is one of the framework's most powerful and elegant features. It allows developers to synchronize data between UI components and backend logic automatically, eliminating the need for manual updates and reducing boilerplate code. In simple terms, binding lets one property mirror the value of another. When the source value changes, the bound property updates automatically, ensuring a live connection between data and the interface. There are two main types of binding in JavaFX. First one, unidirectional binding. This is where one property listens to another, updating only when the source changes. Second one, bidirectional binding, when two properties need to stay synchronized in both directions. JavaFX also supports custom bindings, arithmetic operations, and conditional binding using the binding utility classes. Binding promotes a reactive programming model that improves UI responsiveness and reduces logic duplication. It's core skill for every JavaFX developer looking to build clean, maintainable, and real-time applications. X. In addition to building interfaces with buttons and text fields, JavaFX also allows you to draw and manipulate 2D graphics with ease. Those include shapes like circles, rectangles, lines, and polygons, which can be added directly to your layout or seen just like any other UI components. JavaFX provides a set of built-in shape classes in the JavaFX.scene.shape package, allowing you to visual enhances your applications or even build graphical drawing tools, games, or visual data presentations. Each shape is a node and can be styled, transformed, animated, or grouped just like UI controls. You can change properties like fill color, stroke, opacity, rotation, and scale. Shapes are often placed inside a pan or group for layering and positioning. 2D graphics in JavaFX opens the door to a wide range of creative possibilities, enabling you to build more engaging and interactive visual content within your desktop applications. Animation and effects. JavaFX offers a powerful animation and visual effects engine that allows you to create smooth, dynamic, and interactive user experiences. From subtle transitions to complex timelines, JavaFX makes it easy to animate UI components and apply visual enhancements. Animation in JavaFX. JavaFX provides several built-in animation classes including translate transition, moves a node along the x and y axis. Fade transition gradually changes the node's opacity. Rotate transition rotates a node around its center point. Scale transition enlarges or shrinks a timeline. Custom animation over time using keyframes. Animation can be combined into parallel transition and sequential transition to create synchronized or chained animations, ideal for splash screens, pop-ups, or interactive dashboards. Together, animation and effects help create professional, engaging applications that go beyond static interfaces, delivering motion, style, and responsiveness. Deployment. After designing and developing your JavaFX application, the final step is deployment. Delivering your application so users can run it smoothly on their system. JavaFX offers multiple deployment options, allowing you to distribute your app as a standalone desktop application or even as a modular package that includes all dependencies. Let's walk through the key methods of deploying a JavaFX app. First one, standalone jar file. You can compile your JavaFX application into an executable jar file using tools like javac and jar. Second one, native packaging. Using JPackage, you can bundle your app as a native executable along with the Java runtime and JavaFX libraries. This ensures the app runs on any machine without requiring external Java installing. Third one, web-based deployment. Instead, modern deployment focuses on desktop and modular packaging. Proper deployment ensures a smooth user experiences, makes your application platform independent and eliminates setup issues, making it production ready and professional. Conclusion. Let's briefly recap what we have learned. We started with an introduction to JavaFX, understanding why it has become the modern alternative to Swing. You learned about the JavaFX architecture, including key concepts like the application stage, scene, and the powerful scene graph model. We covered a wide range of UI controls, labels, buttons, text fields, checkboxes, radio buttons, and combo boxes, and how to handle events with elegant Lambda expressions. We explored multiple layout managers. Thank you for joining this session. I hope you understand.